All right, well, good morning, everyone. Thanks for coming today. I know it's a little bit early, so hopefully we can get the energy up in the room and then set it up for all the other speakers today. So I'm Eric. I'm product manager for autonomy here. Well, not here, but at Uber ATG. Uber ATG is the self-driving group within Uber, where we just turned 5 years old, and my team is responsible for kind of driving our first-party self-driving efforts. Obviously, we're Uber, so we're kind of interested in both supporting anybody who is building self-driving, as well as kind of exploring our own approach on that problem. So today I'm going to talk about product management in human-centered AI. So building products in this space, building products for AI is difficult, and building products for people is difficult. How do we kind of effectively navigate that? And then I'll go through some examples, and then at the end of the talk, I'll try to leave 5 minutes for questions and then keep us on time. Cool. So very high level, product management in human-centered AI. Product management kind of traditionally lives at the center of design, engineering, and business. The goal here is we work at organizations that at the very core want to be strong businesses. And by kind of exploring these 3 topics, we can kind of make sure that we're building very focused and very, very valuable products. And then human-centered AI is kind of just this idea that we can use AI tools to build any suite of things of varying value, and some of those things are more human-centered than others, right? There's a lot of benefits to that in that you're closer to the value proposition. There are other difficulties with that, which is humans are very complex and very diverse and very noisy. So kind of how do we balance that and make sure we use kind of these traditional tech principles to leverage in this very unique problem space? And really quick, who am I? Product manager for autonomy at ATG. Before I was at Uber, I was at Facebook working on kind of some R&D projects within the infrastructure AI space. And then I also worked at IDEO and bodied a few startups working kind of in this interactive space. And I was at USC in academia working on human-robot interaction. So did a lot of multimodal communication, gesture generation, that type of stuff. So I guess taking a really quick step back, I don't want to assume that everyone agrees that product management is inherently valuable. So let's really quickly go over and figure out what do product managers do and kind of what type of value do they drive. So very, very high level, right? So this is kind of general. When building products, it is important to understand kind of user needs, the competitive landscape, the kind of context of the individual as well as kind of the individual teams, and that kind of ties into the constraints, and then all of those drive a singular product vision and execution. Singular, I think, singular yet dynamic. So a lot of product management or product development is iterative by nature, because setting something in open loop, kind of building that product doesn't always necessarily work, but by kind of constantly reevaluating the top 4 bullet points, we aim to build things fast and build things effectively. In order to make sure the right thing is being built, the value that a product manager typically adds is that there is someone who is singularly focused or tasked to make sure that we're always kind of measuring these 4 things and always driving the team towards this vision in kind of a focused way. So that's kind of the 5 bullet points that I want to focus on for the value that product managers drive. How we drive that kind of varies in the space, and again, for human-centered AI products, some of these things are a little more nuanced. So generally, where do PMs work? PMs work kind of at the center of engineering, design, and business. They should generally be able to fluidly navigate any of these spaces so that they can collaborate between teams within their own kind of company, as well as external stakeholders. They set vision that people buy into, fully internalize, and use guidance to the work. So this is kind of the visioning portion of this, and then they can kind of do some program management or project management as well to make sure everything is kind of on track. So in terms of design, we kind of think about design as 2 primary bodies of work. One is kind of using design principles to understand what is valuable or what people kind of want. So user research, user experience research. And then there's kind of translating that into actual things to be built, right? So there's product design, industrial design, interaction design. And those 2 things are kind of a dynamical system that is just kind of pushing and pulling, and product managers and designers and UX researchers kind of work together to make sure that the right things are being evaluated and tested at every step of the process. Engineering, I think a lot of us here are engineers or engineers by background. generally we need engineering to help us actually build the products that we want to use. That can vary from like very, very like final product development, or just kind of testing infrastructure, right? That allows us to really quickly iterate on what is being built. And then business. There's a lot of cool things that we can build. I think a lot of us are familiar with really, really cool projects. And then there's a subset of really cool projects that are valuable projects. And I think making sure that, like, with the responsibility to like whatever organization we're a part of, driving the work and like kind of the vision towards something that is valuable, if that is kind of the prerogative of the group, is definitely valuable. So really quickly, how does this kind of manifest itself in like our daily lives today? Not necessarily like in a human-centered AI way. In order to understand constraints, let's just say this is like an iPhone. We're given this phone. How does this actually become valuable? Like the good people at Apple have given us this nice hardware platform that has like camera, compute, connectivity, and like kind of this interface. This is like my personal phone. I actually have not like actively thought about this until I put together the slide deck in terms of like how this is laid out. There are certain constraints I have to work in, which is like this grid. How do I drive value for myself? A few things that I've noticed are that I'm right-handed and I use my thumb for like really quick interactions. I use like both of my thumbs for like typing. If you look at the bottom right corner, those are things that I typically interact with just one hand. And things to the top left are things I still find valuable or interact with, but like typically are more typing engaged. And then there are certain apps on there I just haven't moved since I've gotten the phone. And this is important because if we look at this example, in the product space, in any product space, there's kind of value you want to drive and how you want to get there. There's a few things on this phone or on this home screen that you can see are almost like duplicative in value. So iMessage and Facebook Messenger both have messaging purposes. Because of like the context and competitive landscape, I am personally, quote, forced to kind of use both. Another good example is like Notion and Notes. Notion is like a note-taking app that's like kind of still very startup-y and like constantly rolling out new features, whereas Notes has my notes from the last however long iPhones have been around, right? And there's this kind of like push and pull between product development, and that manifests itself in this. And maybe over time, as like products in general get better, I will converge to a specific set of things. And as a very, very concrete example of like what gets built today, this is just the weather app. I'm like a huge skier, and I use this to track snow in Tahoe or wherever I'm going, but I also use like a different app called OpenSnow that tracks like actual snowfall and like avalanche safety analysis and stuff like that. This is a good example also of product management kind of making sure that the right amount of things are targeted towards the right people. Again, Apple has a huge variety of users, and the difference here being that like this is not necessarily an AI product. They can't fit this weather app to like everyone. Whereas like maybe if it was actually more AI centric, you could have it be a lot more adaptive. Currently, they built this for everyone, and therefore I as a user am forced to use two different weather apps. Generally, let's think about like human-centered AI products then. So there's kind of two components of this, right? There's like the human component and there's like the AI component. So I'll talk about kind of a few nuances of both of those things and see how they map together. So on the AI product side, there's like a few, I guess, features of these products that make product management a little more difficult. So number one, AI products are hard to interpret. So not all methods are necessarily uninterpretable, but like generally kind of like the trend of the industry, or at least in our like self-driving space, is very much becoming a lot less interpretable. In practice, that makes development a little more unpredictable and nonlinear. So obviously when I talk about like building efficiently and building effectively, there's like in traditional tech product development, there's a lot of kind of iterative processes that can be like quite systematic and quite efficient when put into practice. With AI products, that's not necessarily the case, where as a very easy example for us, data collection for kind of training specific models is a huge like initial lift, and we don't get necessarily a lot of returns until much further down the line. And it's hard to evaluate kind of upfront with like a reasonable amount of due diligence, like what type of impact we should see in our products. And then also makes verification validation very difficult, right? So this is kind of where for self-driving, we sit like I guess like in terms of like principally like in the middle of like maybe traditional aerospace or like manufacturing as well as kind of tech, right? So especially on the aerospace engineering kind of manufacturing end of things, there's a lot of like verification validation that we need to go through, and the industry is definitely changing still. So like there's not a lot of industry standards, but actually being able to say that the validation steps I took a month ago is necessarily applicable today, given some change in the system, is not necessarily true. And that makes a lot of these kind of like testing processes quite difficult and quite expensive. And there's a lot of kind of infrastructure work around how do we make things transferable, or how do we make kind of the measures and tests we use applicable, backwards compatible. And then emotionally speaking, it kind of impacts the ability of regulators to trust the systems and user comfort and acceptance of technology. So I think a lot of us here are quite familiar with that end of things. There's obviously certain affordances with technology in general, and when kind of the people building the technology kind of default to saying, well, we can't actually explain why certain things happen. We can kind of show over like large test data that like these things do happen with some amount of confidence, rather than more of like a traditional traceable decision tree almost, or an interpretable approach. It makes a lot of like policy conversations quite difficult, and policy is just like a policymakers and regulators are just kind of like a representation of the general public. So in terms of like tech adoption, that skews that plot quite to the left in some cases. AI products can also be difficult to control. So this kind of goes back to my point about being like systematically able to efficiently build things. One of the difficult things here is when we go and build roadmaps, right? We're trying to get to certain milestones. It's very, very hard for us to say what is actually a reasonable timeline, given that a lot of these systems and like subsystems are tied together in different ways that we actually don't know how specific changes would impact the overall system. So in terms of like kind of exploring the avenue of like how we allocate work and like kind of what type of improvements we might want to make, it's a lot more of a, I don't know if everyone here is familiar with like the double diamond method. It's kind of like this design thinking concept where you expand and then converge, where you expand and like figure out basically all of your options in terms of like the workspace, and then you somehow filter it down to like drive the organization in that way. That expansion component for like AI products can be quite difficult and like quite expansive. So kind of balancing that with intuition and like kind of research inspired methods is quite important for us. And then perverse instantiation and normativity needs to be like explicitly and carefully specified. So there's always like this classic question of people say what they want, what people say they want, what people think they want, and what people actually want. And that's very much the same here with like building AI products, right? There's like the classical like computer science example where professors are like, oh, like tell me how to make a peanut butter sandwich. And like the freshman's like, oh, well, put the peanut butter and jelly between the two pieces of bread, and like how that's interpreted, because it's not very well defined, might be instantiated in a very specific way that is not what the designer intended, right? And I think with AI systems especially, I know there's a lot of really fun examples with like Atari games and stuff where given like some objective function, the game ends up doing a bunch of really, really weird things, but achieves the goal in a very, quote, optimal way, looking at the objective in kind of in isolation. AI products can be hard to scale. So, sorry. I don't know what happened here. I think my laptop just died. Sorry. Can you pull the slide up? Sorry. Well, yeah, my laptop just refreshed. Sorry about that. But I'll talk through it. The AI products can be hard to scale. So generally speaking, when we talk about like hard to scale, there's two components here, and this goes back to like the aerospace and manufacturing side of like the self-driving space a little bit. Sorry, and then perfect. Oh no, sorry, we can go back. Yeah. So obviously we at ATG are building cars, right? So how do we build cars that are like cheap and efficient and scalable is by kind of committing to a specific set of hardware and software builds that we eventually scale up. This is kind of like how car manufacturers work. This is how like any like iPhones work. This is like how any like hardware product kind of scales, is by committing to something. One of the difficulties with that in like the AI space is like there's a lot of improvements that are constantly happening, and it's quite difficult or potentially inefficient to overfit to what's existing today. So that there's like a very fine balance of like building in the flexibility for like future improvements, as well as getting to where getting to like a valuable product today. Scaling AI solutions is also difficult. One of the classic issues for us, or anyone in the self-driving space, is like transferring between operational domains, right? It's like, how do I know that driving in Pittsburgh is the same as driving in San Francisco, like with some confidence, right? Like those two things are not necessarily the same. I think the classic example, especially if people are familiar with Pittsburgh. So HEG is based in Pittsburgh. There's a thing called the Pittsburgh left, which is this behavior that some Pittsburgh drivers exhibit, where if you have essentially an unprotected left in like a two-way lighted intersection, when the light turns green, the first driver turning left will just like cut off the lane going straight. That is a behavior we obviously don't see in San Francisco, but I remember very early on when we were kind of looking at the logs, we were saying there was very, very weird emergent behavior. There's actually quite a few CMU papers, like on like end-to-end learned self-driving, where Pittsburgh data sets cause the car to do very, very different things than, for instance, like a data set from like Palo Alto. And scaling that, and like this again goes back to like kind of the verification validation steps, is very, very important for us. And therefore there's like a lot of work on our teams to build out not just like the self-driving tech, but tech that supports scaling that, especially as we kind of look a little bit into the future. And then in situ experimentation and validation can be incredibly expensive. So in situ meaning kind of actually driving on roads is super expensive, and especially like, again, as we go like into different operational domains. We recently announced that we're driving in Dallas and DC for like mapping purposes, but like you even think like logistically speaking, getting a car from Pittsburgh to Dallas and like setting up all of the infrastructure there is very expensive, and it's hard to see how this scales over time unless we like come up with some pretty clever methods. So next. Oh, perfect. Thank you. And then people as users can be quite diverse. So obviously people are very different from one another in their needs, their preferences, their styles, and their backgrounds. That's awesome. That makes people like super interesting. That also makes product development very difficult, right? So back to the weather app idea, you can't necessarily just build a singular weather app that is a car that drives on roads with everyone, right? AI has this like strategic benefit of being more adaptive and can support more diverse individuals. And I think that's a lot of the applications of AI in products today. But as we kind of move the AI component of our products closer and closer to like the human interface, there's a lot of potentially, I guess, more difficult components of building products like that we need to consider. And I can go over some of what we do later. People can also be inexplicable. So when you ask people why they do things, oftentimes they can give an answer. They can't give a full answer. And that makes things very, very difficult. And again, in terms of leveraging AI, this is like actually a core strength that we do. We try and leverage as much as we can. And academia has been doing a lot of interesting things in recent years, such as like domain randomization and like just generally like self-supervised learning. How do we figure out what systems are doing such that we can actually use that as like an intermediate representation, like a representation that we're actually happy with, rather than having people explain why they do things and why they want things. And kind of bootstrapping like AI approaches with kind of traditional UX research approaches is something that we found very effective. But the key thing here is like when we use those UX research like methods, making sure that they're forwards compatible with future, maybe more learned and more scalable approaches in the future is something that we actively think about a lot. And then people can be malleable. So this is a huge strength for like us, as well as like any people working on kind of like new technologies with new affordances, right? So affordances being that like what a product suggests to humans or to users. For instance, like the classic example before this is like door handles. There's like door handles like that, and then there's door handles that are knobs that might afford like pulling rather than pushing. How do we do that? How do we set expectations for interactions, and how do we set expectations for how products should be used with like self-driving? Like a classic example for self-driving like HRI is there's an experiment from like Stanford and Virginia Tech where they basically shelled out the inside of a driver's seat and had a driver just drive with their hands like on the bottom of the steering wheel, drove around the campus and then kind of saw how people reacted. Potentially one of the things that you could help self-driving cars drive safer is by kind of affording to users or other drivers around it to be a little more careful, right? And like that's potentially one part of the approach. But in order to do that, like there's a lot of very like proactive and explicit design work that needs to be done. And it's a fine balance of like, before we release anything to the world, like at scale and like really allow that to shape expectations, making sure that when we ship something, we're quite confident it molds expectations in a way that we're happy with. So again, just in summary, these are like the 7 points that I just really quickly talked through. AI has interpretability issues, controllability issues, scalability, and like there's novelty that we can leverage. And for people are diverse, sometimes inexplicable and quite malleable. So what do we do at ATG? So my team is responsible for first-party self-driving. Our kind of like mission statement is to define and deliver the autonomy software of choice for self-driving products that are viable and valuable at scale. Our user personas, I guess, are riders, mission specialists. So these are like kind of our operators as we're not in NVO yet. Road users, so drivers, pedestrians, whomever, and regulators, or like, I guess, the general public, right? Like a proxy for the general public. Our general objective at ATG and for my team is to actually build vehicles at scale eventually, right? So build vehicles at scale with self-driving systems, manage full fleets, and then kind of build out this network or platform that kind of grows over time, right? So there's the ends here are like the scalability components, and then self-driving systems is kind of where we're focused on now. Like how do we get that up and running? So how do we go about defining requirements or product requirements for a self-driving product? At a very, very high level. And I mean, we take a traditional kind of approach where we decompose high-level requirements. They need to be like safe or acceptably safe, legally compliant, and comfortable and valuable. Comfortable and valuable are split up in that comfortable being like the ride is good, and valuable being, for instance, like the functional value is there, right? Like I can have a very comfortable ride that gets me to like my destination 20 minutes after like where an UberX would, and then I can also have a ride that gets me there 5 minutes faster than an UberX, but like I'm like motion sick by the end of it, right? So PMs kind of like on our team need to understand how things work, so like how autonomy actually works, how things get tested. So we work with a lot of our other teams to make sure that verification validation works, and how these other teams think, and these other teams both being internal and external stakeholders. And these are kind of like the other teams that we interface with internally. We have a public, this is from a public site that we have up on our self-driving safety case. When I say acceptably safe, this is how it decomposes. These actually like kind of are click-through. This is from our safety team, but and our safety team is a lot of like, kind of like, it's a mix of policy and engineering work. We're here to operationalize that into like an actual autonomy stack that is built and like runs on roads. So this is kind of like where the high-level safety requirements decompose. Verification and validation is a huge step for ATG in general and self-driving as an industry. Industry is still kind of developing, so it's a combination of using like off-the-shelf standards like ISO 262, engaging with SAE and like kind of all these other companies, but also building out what we think is best, right? The way I think about it is kind of like de-risking. At some point, we will go and make this pitch for NVO readiness, and it's de-risking like what that pitch looks like and making sure we have the best validation testing we have. So this is like an example of our sim tools and how we can potentially do different things like fuzzing or replays on like real logs. So this is a real log that we can extract different features of from like our autonomy stack. And when we write requirements, we not only need to write requirements that are good, but write requirements that are testable and testable in the suite that we have. So we use both. Use both SIMS testing as well as track testing. So we have a track in Pittsburgh that we run like gating tests through. The next thing is, like, as a team, how do we make sure that what we're building is not only safe and legally compliant, but how do we drive value in like what we're delivering? So our goal is not to only deliver the safe and functional ride, but like an enjoyable ride. People don't actually necessarily know what they want, right? So how do we actually get to a point where we understand that is something that we actively work on. We focus on a specific user group that we find is like the most representative of our near-term kind of goals. And again, back to my previous point about shaping expectations, we actually evaluate not only what people perceive about our products or about the industry, but how we might use different mitigation techniques to kind of control that perception. In terms of like understanding user needs, data and metrics are all proxies, right? By definition. One of the things that we think about is how do we use off-the-shelf data and like kind of industry standards to model our user needs as well. So they're like, if we think about it as like fitting a linear function or like a 2D function to something, you can look at trends to understand like the slope, and you can look at like initial data that you can collect as like a y-intercept, right? So we use a lot of off-the-shelf data, including like trend data, as well as a range of kind of in-situ data that we've collected from track and from road. And they kind of range from qualitative to quantitative. And as an example of like the matrix we think about, there's like one dimension of access or like accessibility to the data, and there's another axis of value. And we're just kind of trying to trend up in a way that's like efficient and like somewhat reasonable. And then at a high level, we set goals along these metrics, right? There's like kind of 5 components of metrics that I personally think about. There's like, what is the metric? What is the goal that we want to hit within that metric, which is kind of the XX here? What is the measured value of that metric? And how do we actually kind of improve that metric over time, right? So if this is like our measured value to something that, let's just say we consider XX as readiness, how do we make sure that we get to XS as efficiently as possible? In practice, this is actually what it looks like. Because it's still a proxy, we don't actually know with full confidence that this metric is like perfect. If we're wrong and our measured value for that specific thing we're trying to measure is more conservative than it needs to be, we waste some amount of time. If it's less conservative than it needs to be, we actually end up shipping a bad product, right? So over time, not only do we need to make sure that we're working to drive kind of like the measured value of a metric up, we also need to make sure that we're constantly kind of reevaluating how effective we think that metric is. And then in terms of like actually driving work, this is how we think about like self-driving at a very conceptual level. Is there's a lot of features or like subsystems that we have. They tie one to many into like a bunch of functions that the car does. For instance, like ACC or like lane keeping. And then we have certain goals, maybe contextualized to different ODs, and we want to hit those goals, right? So you can kind of like transcend this graph back and forth to figure out like if you want to hit certain goals, like what are the things that you can improve, and vice versa. It's like if you improve a certain feature or subsystem, like how does that potentially impact the goals that you have? So in summary, we want to live in kind of the center of both of these Venn diagrams. There's a lot of value that product management can provide if leveraged effectively, but kind of being self-aware about like the nuances of like the industry, the type of product we're building, as well as kind of like the nascent nature of the field as a whole is super important. And I think we can just do well to think very actively about these and make sure that we develop our products like kind of cohesively across these 3 domains, across humans and AI products. So with that, thank you. And we have a couple minutes for questions.
We have a few minutes for questions if anyone has any questions.
Hi. Can you address the issue of AI standards and in particular, SDV standards with so many different companies around the world working on this technology, making it sort of a global versus a US-centric standard? I mean, how do we how do we deal with that? EU just came out and said they want to have their own standards sort of in technology, and so, you end up sort of with the wireless tech model where you have different standards all over the world. So how do we address that? And, I'd like to hear your thoughts. Thanks.
Yeah, I think wireless standards is a great example, and I think there's a few other industries maybe that are like more segmented than I think on principle they maybe need to be. I think in general, my opinion is that we first need to agree on like very, very high level principles and what needs to have requirements set around it, right? There's a lot of working groups or consortiums, I guess, that various companies, to your point, are kind of all engaged in. There's a few different approaches that can be taken. One is like, I think there's been public talks about, can the US government or whatever body, right, like have like a test set that like everyone is tested against, and there's like some pass-fail criteria. There's a lot of difficulties with that, especially like in terms of like transferability or kind of applicability. So that's one approach. The other approach is like subsystem level testing, which is more of like an aerospace approach. Is like, I'm going to assume that if all my tolerance stack-ups like work in a way that like more traditional fields do. I personally don't know that would work. So right now, a lot of what I've seen happen is everyone is kind of following or taking inspiration from like the ISO or SAE standards that they can, as well as kind of pushing their own internal processes, and then surfacing those processes to like these working groups to see like what might be most effective, right? But again, like I think the first step for us really as an industry is to agree on super high level principles that we're going to design our tests or design our processes against, and then it's almost like a top down approach versus like kind of everyone's like, oh, I'm going to go bottoms up, right? So we definitely need it, and I think it's happening soon though.
Thank you. Thanks, Eric. Excellent presentation. So I just have a quick question. So in terms of AI uses, right? So it's pretty broad across Uber, because if you're talking about the ride sharing is mostly on the mobile platform, recommending to the passenger and all, right? On the other side, if you're talking about AV, right, autonomous, then you're talking about probably GPU and things like that. And can you give a quick overview of the hardware software platform across Uber? I mean, what you use for AI primarily?
Across Uber as a company, so like to your point, like so I guess we have a bunch of like different business lines, right? So like I think generally we have rides, eats, freight, which is like our shipping, and then we have like new mobility, which is Jump, and ATG and Elevate, right? So other than I guess ATG, no one really does like on-prem, like high capacity, like on-prem, like anything, right? It's all like cloud-based recommendation systems and whatnot. We actually have quite a few blogs open on like our AI platforms from like the rider or like kind of traditional business side. For ATG, we currently do a lot of like in-vehicle compute, right? So we have custom like GPU compute systems in the trunk of our cars. We have like a specific tool chains that we use for like training our self-driving models, but that's actually in practice quite separate from like what we do for like the rest of the business, because it's just so different. I forget I believe it's called Petastorm, but if you're interested in kind of like traditional Uber, there's a few really good Eng blogs on that. Yeah.
All right, let's thank Eric one more time for a very insightful talk about the difficulties of product management at ATG. Thanks, Eric, very much.